Awesome. So I guess we can start from here. Hi guys, this is Chris from Dorahacks. Very glad to see you guys again. I will be the host for today's workshop sessions. So we are very happy to have Samuel, who is the CTO of Tatum, and Albert, who is the chief researchers from the BlockPI. To join us as the speaker for today's product demos, for today's workshop demo sessions. So before we start, please allow me to briefly introduce the Klaymakers background. So this is actually the very first time that Dorahacks to host Klaytn's hackathon on our platform, and I believe this is one of the biggest hackathons on Klaytn history ever. For this hackathon, we have Tatum and BlockPI and other sponsors like AWS, HashiCorp, Crust to join us, and also we have Chainlink, Questable, Pocket, Warhome, and a bunch of others well-known, reputable projects to join us as the community partners. And this is the virtual hackathon, so we are very welcome global size developers to join us today, for the Klaymakers 2022, and we will have 360K prize pool for 5 main tracks from 6 sponsored challenges, and they are Klaytn Core Plus track, Metaverse and NFT tracks, DAO tracks, 5+ tracks, and public goods tracks. And we will host a series of the developer workshop. We will officially kick off the Klaymakers 2022 in the next Monday, which is the August 29th. And we will have project demo days and sessions for top list finalists of this hackathons, and we will have the product vouchers to following up. So if you are developers, if you are building on any of the tracks that above, please feel free to join us, and you are very welcome to join us. And here is the Discord. You can scan this QR code to join the Discord, and we are always here to answer any type of questions from you guys. Cool. So without further ado, let's welcome Albert first to start this workshop sessions. And for all the audience, if you have any questions during the sessions, please feel free to ask in our Binance Live or YouTube chat room. We will shoot these questions for you guys to the speakers. Yeah. So Albert, it's your time. Let me start my screen sharing. Yeah, you can go.
Am I on the screen?
Yeah, we can see your screen now.
Okay. Thank you, Chris. And thank Klaytn to give us this opportunity to have this workshop. My name is Albert. I'm a researcher on the team. My job is technical research and community technical support. And I am very excited to represent BlockPI to join this hackathon and give the workshop speech. So to the audience, welcome to join our workshop, and nice to meet you all. The title of our workshop is Better RPC Service from BlockPI Network. It has been 2 months since BlockPI Network integrated with Klaytn. Thanks to the BlockPI community, we have built the robust infrastructure for Klaytn ecosystem with a highly distributed network. Since BlockPI has already finished several milestones of the product, it's a great chance to sponsor the Klaymakers22 and introduce it to more community members in this workshop. We want developers use BlockPI API service and help us improve it and give feedbacks from the user side. I will follow these outlines in my speech. I will start by giving you a brief introduction of BlockPI network, explaining network structure and the challenges, and show you how to use BlockPI network IPC service as a new user. After all that, there will be time for you guys to ask questions. BlockPI is a decentralized multi-chain acceleration layer. It provides a stable and reliable decentralized API service for all Web3 developers. Many dApps are still using centralized IPC services, and there are some large providers in the market, and that will bring some problems. Users are vulnerable to outage. In addition, the scalability is limited. Many of you must have experienced IPC errors from your wallet. Most of them are due to the limit of the IPC providers. BlockPI designed a decentralized network to solve the problem and provide scalable as well as high-performance IPC service for dApps. We are very honored that so many people have endorsed our idea. We closed a $3 million seed round earlier this year. This round was funded by the investors below on this page. There are several main roles in our network. We have a user to send the requests. Hub is our management system for users and nodes, and accounting system of the BlockPI. Gateway is responsible for load balance. It will process and route the requests. Hypernode is the IPC node in the BlockPI network. We also designed validators and the fishmen in the network to guarantee the healthy operation of the network. In this phase of the BlockPI testnet, node operators are able to join BlockPI network as hypernodes. We will open up gateways and validators in the future. Okay, this slide shows the whole structure of BlockPI and the life cycle of requests. The uppermost with a blue frame is the BlockPI hub, which is a server run by the BlockPI team. Its functions include managing and maintaining user data like registration information, account data, KYC data. It also maintains the RU accounting system. In other words, the expense of using the BlockPI network IPC service, and some other necessary features. The rightmost is the hypernode, which are the working nodes that process IPC requests, accept the requests from the gateway, and forward them to the IPC interface of the corresponding blockchain. As the main decentralized IPC node in the BlockPI network, it is usually run with the full node of the target blockchain. More nodes in the network can respond to more requests and achieve higher concurrency with lower latency, which is what BlockPI is after. More hypernodes will also solve the single point failures and limited scalability caused by centralized infrastructure, and provide a more continuous and stable API service for dApps. On the left of the hypernode is the gateway. It is the portal for users to use the BlockPI network. After a user request reaches the gateway, it is rotated to a corresponding hypernode based on the algorithm of the balancer. Below is the validator, whose job is to get the latest gateway and hypernode reports from the hub and verify their locally stored data. Validators are the backbone of the network. The entire validator community forms a blockchain network and produce the validation data into blocks. The validator will be in the network in the future and will also be open to the community. The fishman on the left on top of the user, which can be thought as a special kind of ordinary user. They conduct sample request tests on gateway and the hypernode to determine if they are reliable. The real user here can be regarded as an individual or a debt. Users who want to use BlockPI networks need to register an API key to the hub for the service. With this API key, the user makes RPC requests to the gateway, and they are processed by the BlockPI network. Okay, here I want to share some data of BlockPI network. We launched our testnet in June this year and have received more than 4,000 applications. Finally, over 70 new operators who came from 14 different countries and regions joined our testnet. And they are running Hypernode and running the full node of Klaytn. They are processing the RPC requests for Klaytn users. The performance of the network processing RPC requests is below. The medium response, in other words, the P15 latency is 25 milliseconds. The P90 latency is 77 milliseconds. The success rate is more than 99%. Peak QPS can reach 292K. And at the same time, the network was still with a high performance and the success rate. These results are calculated from our stress test recently. By the way, Klaytn reminded us that there will be increasing demand from the Klaytn testnet due to this hackathon. So we will also launch our service on the testnet BlockPI next week. This page is a user guide. If you have not tried our RPC service, it is as simple as 4 steps below. And you will have your own exclusive RPC endpoint. The homepage is here. And you can also find this user tutorial in our docs. Okay, let me show you and open the homepage as a new user. So this is what shows after you navigate to our homepage. You are welcome to register with your email, or you can just log in with your wallet. Let's try to log in with the MetaMask. And skip this part. You can input the email address to link with your account. Okay, so after logging, it is asked to generate the API key. Let's generate one. Type in the name of the key. Let's click generate. Okay, now we are on the main page and the key is on the list here. The next step is to purchase some RUs. Let me explain a little bit. RU is request unit, which is a basic charge unit to calculate the usage of the network. Different types of RPC queries consume different levels of BlockPI network resources. You can find RU price table in our docs. So let's try to buy a package. Right now, there are 2 packages. One is free and one costs $0.1. We will adjust and provide more packages in the future. If you want to buy the premium one, you need to deposit some fund. Since we are in the testnet stage, and I recommend you try the free package first for regular demand. For those dApps who have high number of RPC request demand, you can contact us and we will deposit some fund for you. Let me buy the first one first. Okay. Now you can see there are 100K IU here, and you are good to go. The next step is to copy this endpoint and replace the RPC URL in your wallet with this URL. Let's take the MetaMask as an example. So open the setting of the MetaMask, go to the networks, and choose the Klaytn mainnet. There's a URL address to be input here. And replace it with the new URL you just generated. And you are good to go. Okay, let's go to the slide again. Here comes to the final part, the challenges. We give 2 challenges. The first one is develop and build. The main direction of this one is to develop integrations to improve the Klaytn endpoint node. As I mentioned in the BlockPI network structure, Hypernode works with the endpoint node. So try your best to improve the RPC performance of the endpoint node so that it provides better RPC service in the BlockPI network. Here are some ideas, but are not limited. The first one is request cache. It is to save the results of request methods, which will return fixed messages in the cache. So it can be for instant response. The next one is P2P global network and fast broadcast. This idea is to improve the Klaytn P2P network communication and improve the communication success rate and optimize the broadcast speed. The next part include offline storage, hot and cold storage, query middleware. For offline storage, offline node can still write data and provide historical data. For hot and cold storage, because storage is limited, with the block data growth, you can classify different kinds of block data to be saved in the hot or cold storage. And therefore, develop the corresponding middleware to fast get those data. The next part is fast sync. So try to improve the synchronizing speed of the Klaytn endpoint node. The last one, so if you have any other, you develop any other tools to help the community to better use the BlockPI network, you can also submit your results. So for this challenge, there are 3 prizes paid in Clay. My technical team will assess your submissions and give 3 prizes among them. To submit your work, please provide a URL to the open source code repo and provide a URL to interact with the application and record a video showing how to use it and share it with us. And finally, you need to provide your ERC20 address so you are able to receive the rewards. The next challenge is for developers who are running their own dApps and products and integrate BlockPI network RPC service. $4,000 worth Clay will be distributed to dApps who integrate BlockPI network RPC service in their product. The team will list the dApps who successfully have done that and evenly distribute the prize to them based on the criteria. Developers will need to provide their product's URL, the BlockPI RPC endpoint they are using, as well as their ERC20 address, so you are able to receive the rewards. For both challenges, The email where you submit the work is info@blockpi.io. And please state in the title that this is Klaymaker22 challenges. Okay, this is my speech part. I will give it to Chris.
Great. Yeah. Thank you very much, Albert, for this very detailed introductions. Let me check. Yeah. So there is questions from audience asking that when will testnet coming for BlockPI?
The testnet is already kicked off in June this year.
Got it.
Actually, we are in the period of the testnet. Oh, if they are asking our service launched on the Klaytn testnet, it will be the next week.
Next week.
Right now, we are providing service on the mainnet of the Klaytn.
Mm-hmm. Cool.
Yeah.
And so, well, like, well, can you briefly introduce like what is the qualification for running like a node for BlockPI?
Actually, we have a link to submit a application.
Mm-hmm.
But we are at the stage at the middle of our testnet. If you want to join our testnet, I recommend you go to our Discord and ask for the link to fill the form.
Got it.
Yes.
Awesome. Yeah. Cool. Thank you very much.
By the way,
yeah, please go.
Chris. By the way, I didn't mention we have the Discord and the Telegram and Medium. It's on the bottom right corner of our main page.
Mm-hmm.
Those links. Yes. Yeah. Thank
you. Audience, if you want to know more details about BlockPI, about the nodes, about the mainnet and testnet, please feel free to go to search BlockPI in Google. And I believe the first link will direct you to the BlockPI's official website, and you can find all of the social channels for BlockPI. And please feel free to join BlockPI's community and try to engage and ask any questions for BlockPI team. Yeah, cool. Thank you very much, Albert, for this workshop. And
thank you.
Yeah, and now let's welcome Samuel from Tatum. He is the CTO of the Tatum. Yeah, and he will provide another short workshop. Yeah, Samuel, it's your time.
Thank you, Chris. Thank you, Albert, for nice workshop. Welcome, guys. Welcome, builders. Welcome, developers, to today's session. What I'm going to show you today is basically what is Tatum, how to build applications on Tatum, and how we, as a framework, could help you build blockchain apps using Klaytn or any other services. So let's start from the scratch. Let's explain what Tatum is and how we can help you. Basically, we are the most used Web3 developer stack for developers. We're trying to build tools for you to build blockchain applications faster, better, and even sometimes without knowing what's actually happening on the chain. Because let's be honest, sometimes it's really a miracle how some things are working. And a lot of developers are actually not skilled. They are new to the blockchain. They don't know where to start, how to code, how to basically architect the whole application. And that's where we are coming in. That's where we are trying to help you. That's where we are offering a different set of features which you can use in your application. We are basically a set of API calls. So you can leverage our framework via REST API. Plus, we've built a lot of tools around the API, some, let's say, SDKs for different languages or key management system and other, let's say, third-party open source tools, which are all available on our GitHub. And today I'm going to show you a couple of operations you can do, how you can build some use cases or some applications using our framework. So let's just dig into it. First of all, everyone who want to do something with us, you need to sign up, of course, because you need to get an API key in order to communicate with the cloud services. So if you go to the Tatum.io, you will actually open our web page where you sign up into our dashboard for a new API key. I'm just going to sign up by myself as myself. I already have a lot of different API keys. We offer free API keys for 2 API keys for mainnet or testnet. It's really up to you. Those API keys are unlimited. You can play around and do whatever you want with basically every feature we have. The only limitation is the throughput. But like for building, that's just fine. So if you click create API key, you can create a free API key, which I don't have because I have depleted all of mine, but you'll see the free one here. And once you create the API key, you will be able to show it, copy, and work with it. So the onboarding process is pretty simple. As basically in any other application out there, you need the API key and you need to build something. When we are talking about building, we have a lot of different guides, tutorials, blog posts, where we're trying to explain different patterns or things, how you should build apps, what you want to build and how to achieve that. You can find all the resources from our main page inside the resources section. When we have a huge API doc, we have a documentation, we have a blog where we are describing a lot of stuff. So today we will dive probably into the API doc, into the documentation, where we are trying to describe basically every operation, every endpoint, every feature we offer with the payload and everything you need to know. You can see there's quite a lot of things on the left side. So the variety of the things you want to do or build is basically endless. We support more than 40 blockchain protocols, and the integration of those protocols is on a different level in our platform. We are not only the RPC provider. We give everyone an access to the RPC nodes. So everyone who has application or running application or want to play around with the RPCs, anyone can like call any RPC of the supported blockchains we have listed here. But on top of those RPCs, we have built, let's say, different layers of abstraction, because we understand that RPCs are hard. It's hard to build something, especially if you're a new guy in a blockchain world who don't know like what actually is an RPC and what's the data which are being returned from the calls. We understand that, and we're trying to tackle it with some kind of abstraction framework. So imagine the situation that you want to mint NFTs, for example. You really know your business case. You want to mint NFT, and the NFT will represent some ticket to some football match, let's say. You really know how to do it from the business perspective, but you don't know how to code it in a blockchain, because there is so many RPC stuff, there is so many smart contract development stuff, etc., and you are just lost. And we know that this is happening a lot. That's why we have created these abstractions on top of RPCs, where, for example, if you want to work with the NFT, you just call a mint NFT operation, and you don't need to take care of how the transaction is being constructed, what's actually on a blockchain, what's not on a blockchain, etc. So these kind of, let's say, ready-made features, there is a lot of these kind of ready-made features are available for you on a platform, and the only thing you need to do is to basically understand them and try to connect them together. And that's what I'm going to show you today on a live demo. So when we open a Postman, which is a nice API tool or API client for working with different APIs, I have prepared a small workshop for today's session where there is a bunch of API calls which represent some features. Some of the API calls are simple, like for example, direct RPC call to the node. Some of the operations I'm going to show you today are actually invoking a lot of logic behind in our cloud services, and it like highly abstract you from those nasty operations you would perform, and for those, let's say, performance like heavy operations. But we'll get to it. So today, let's do very briefly. I'm going to very briefly show you what kind of things you can do and what kind of features you could imagine we are offering. So as I said, like everyone is offering RPC access to the nodes because, you know, everyone is used to working with RPCs, and sometimes every framework, like even with the best abstraction on top of it, it can't cover every edge case. So if you don't find some operation in our abstraction, you need to go a little bit down into the, let's say, into the low level stuff. There is always an RPC node, an RPC call you can perform, and you can build everything by yourself. Inside the URL operation, I have Tatum API endpoint. The endpoints are also available in the API doc. You can see different. We can see two regions, one in Europe, one in US. Soon we're going to launch a new region in Southeast Asia. So right now I'm going to use my European region with European API key. When you want to perform the request, you need to authorize it with the API key you have copied from the dashboard, and the authorization is performed as a HTTP header where you enter the API key inside the header. So the RPC call is pretty simple, straightforward. Any RPC operation you want to perform, you just use the standard RPC say, methods you wanna use, and you can see the standard RPC response. It's very basic and straightforward. You don't have to run your own node, and you can build everything you want. But what RPC calls or RPC node doesn't give you, for example, is the ability to generate wallets or private keys or addresses, or let's say send transactions without the necessity to sign it and build the transaction using some complicated SDKs. And these kind of operation we have abstracted as well. So right now we are moving from the, let's say, the low level RPC abstraction to, let's say, first layer above, where you can, for example, easily generate the wallet. And when we are generating wallet, we are generating basically HD wallet based on some derivation paths which are common for the blockchain you are working with. We are working with Klaytn, so in the URL you can see the Klaytn. If you want to work with, for example, with Bitcoin, you can call generate wallet for Bitcoin. If you want to go with Ethereum, you can call wallet with Ethereum, which is basically the power of abstraction on our side, where we are trying to give you the same, let's say, look and a feel for different blockchains. So you are coding the application once, you can run it on multiple different chains. So we can generate the wallets, we can generate the private keys from the wallet, or we can generate an address from the wallet. These operations, which are, let's say, sensitive to be sent via internet, from the sensitive, I mean, you are generating mnemonic or private key or working with a private key. And you should never ever send private keys over the internet anywhere, even to us, even to no one. The private key is your thing and you should keep it secret. So yeah, you may ask, why do you have like generate wallet stuff where you are generating wallets via API? And the answer is because for demo purposes, it's great. If you want to fast track something, it's great to just play around with it. But we have other ways of working securely with the wallets and the private keys, which I'm going to show later today on a workshop. So keep in mind today, everywhere you're going to see private key or everywhere you're going to see mnemonic is just for the demo. Your product applications shouldn't be built like that. Otherwise, you are too risky and you are exposing your secret key, which is wrong. So we can generate wallets, we can generate addresses, private keys, which is great. Basically, when you want to onboard your users to your application, every user needs a wallet and every user needs an address in order to communicate or receive some assets or send something somewhere. So with these three operations, we've basically covered onboarding of your users. What's next here? Let's this really depends on the application. Some applications, they want to, for example, read some information from a blockchain, right? They want to, I don't know, see every block and parse every transaction and detect every NFT, for example, inside a transaction. You may build some, let's say, analysis or some analytical application where you want to perform some operation on a chain. So in order to do that, you need to basically to read blocks. You need to read blocks from the chain, and you need to read block by block, let's say. For that, we have again nice abstraction that we're gonna get block from a Klaytn with some block number, and you can see the result is a block without any transactions. Another thing, when you want to read the blocks, you might read transaction as well. So you may read transaction one by one. I believe this is the mainnet one. So let's check the transaction, and you can see that, okay, transaction is present. I can see the logs which were like produced from the transaction. You can parse some information from your from the topics. In general, when if you're gonna call the RPC call get transaction, you wouldn't receive the logs built in automatically for the transaction. You would have to call like get transaction receipt and get transaction. What we are doing, we are just calling that for you on our side and just give you full information we know about the transaction itself. Okay, you say this is great. I can read some information. I can read some data. I can maybe detect some operations from the chain, but I want to send transaction, right? I want to send my Klaytn from my wallet to someone else, or my users want to send Klaytns in my application. How can I send it? How can I build a transaction? I see that there is some library. I need to sign something. I need to build something. We have, again, some abstract endpoint for you where you just say, hey, I want to send transaction. I want to say Klaytn from this private key, from this wallet to this recipient, and how much I'm going to send. It's like 0.0001. And you're just going to send it. And the result of the operation is transaction ID. When we check the transaction in Explorer, we could see that we have actually sent 0.0001 Klay from myself to the recipient. So you don't have to do anything. You can just really build your sending logic with one API call, which you may say, okay, but I can do it in the Klaytn SDK. I can do it locally. That's true, but the SDK for most of the blockchains, those SDKs are written for 1, 2, 3 languages tops. So if you're not a developer in I don't know, JavaScript or Golang, or I don't know what other languages are there available, you basically can't build and can't sign transaction in your language of choice, right? On the other side, when you have an API, the API is platform agnostic, right? You can call API from every application, even it's mobile, even it's I don't know, C# or it's I don't know, Ruby on Rails. each of the protocol, each of the framework and the language has some API like capabilities. So you are not tied to work on in a specific language. You can use the API everywhere. So this is another nice operation, how to basically send some Klaytns from one address to another. But you say, yeah, okay, but this is great. But I have some smart contract on Klaytn deployed, and I need to communicate with it. For example, I don't know, I have some DeFi protocol there, or I have some auction contract, and I need to interact with the smart contract. Yes, we know, and that's why we have the invoke smart contract operation available, where you basically say which smart contract you want to call, what kind of method you want to invoke, what's the ABI of that method, basically what's the interface, and the parameters. And once we have this, we can call the smart contract operation for you, and you don't have to build you don't have to build that integration by yourself. This is again great for projects which can't leverage the native SDK built by the blockchain, built by Klaytn or anyone out there, because there is just no such SDK for C#, for example, right? So again, one API operation where you can call basically any smart contract function on a deployed smart contract on the chain. This was a read operation. This was a balance of. What I've done here, I check what's the balance of my address on top of this ERC20 token. If you want to invoke some write operations, which are doing transactions, you just need to add the private key here as another parameter. And once you add the private key here, your private key, you will perform a blockchain transaction, which will invoke some smart contract logic. So again, you can really interact with the contract from everywhere. So what I've shown in these like 6 or 7 operations, I've shown you that you can work with the RPC nodes easily. You can perform any operation on top of the RPC node. You can generate the wallets and private keys and addresses from the wallet. You can read blocks, you can read transactions from the chain. So you are basically aware of everything that's happening on the chain, and it's important. You can send Klaytns from one address to another address, so you can transfer assets. You can invoke basically any smart contract method, and you can interact with your smart contract via API. So this is like, only these 7 things are pretty powerful, and you can basically build whatever you want, because it's really the necessary like building blocks for you. But we don't stop here. We have more funny stuff to show you, because we understand that even this, let's say, abstraction I have shown right now, it's complicated. Because imagine the situation that you are building some customer-facing application, right? You are building, I don't know, some wallet app for where your users are going to sign up. They will have generated addresses. They can receive some I don't know, Klaytns. They can receive some NFTs. They can receive some tokens which are on top of the Klaytn network. And for example, what do you want to do? You want to notify your customers about the transfers, about incoming operations on top of their addresses, right? For example, I don't know, I have an address and I have received new NFT, right? Someone sent me an NFT, or on my NFT, I have received some payment from one of my customer, from customer of the customer, right? And what do you want to build? You want to build a notification service for your customers that something has happened on their address, which is, let's say, first more complicated use case than just calling 1 or 2 operations, right? If you want to really notify your customers that something has happened on their addresses, you need to actually read every information from the blockchain, block by block, transaction by transaction, and detect some important stuff that's happening on top of the set of monitoring addresses, right? Yes, you can say, but I can have WebSockets. I can subscribe to the WebSocket monitoring, right? I can like create new subscription. Just tell me, hey, notify me when something happens on this address, right? Yes, you can do it, but that's not scalable. It's working for hundreds of notification or for 100 addresses or 1,000 addresses. But if you have million addresses you need to monitor, your node won't be happy that he has to do that. Plus, every time you reset the node, your notifications are stopped. And if you want to have like multiple nodes on which you're going to subscribe, you're going to receive duplicate notifications, right? So we need to filter them out. So the best way how to actually be notified about anything is to read which is important for you, right? Okay, so the get block, right? The get block operation and the transaction operation. But in order to be up to date with all the information that are like happening on the chain, you need to read every block. Block is 1 second, right? So basically need to call get block every second, get all the details from the transactions every second for all transactions inside the block, and do some parsing. You may feel that, okay, it started to be complicated. And when you say like all this must be done in a second, you need to scale that, right? You need to do a lot of stuff on your end. So it's going to be costly. It's going to be, let's say, buggy, and the performance is questionable. We are doing this all for you because we are like we are fetching all the blockchain information. We are indexing all the information from the chains, and Klaytn is one of that. So what we give you is we give you a simple way how to subscribe for notification on a specific address. So it's what I'm saying, when anything is happening on this address, when any NFT is coming or going, any token, any native asset, you will receive a webhook to your URL. So that's super great because with one API call, you are constantly starting to listen for everything that's happening on your specific address. I've already performed some webhooks. Yes, I've already like subscribed to that in the past, and this is the webhook recipient side where I can see everything that's happening, and you can see, okay, I have sent one clay from one address to another, or maybe I have paid some fee from my address. I believe I have minted some NFTs before. Yeah, here I have minted some NFTs and I receive it in my address. So basically any information that's happening on a chain, you are receiving real time as with these like webhook subscriptions. And you don't need to code anything, you just subscribe and you don't care. So this is, let's say, one of the most advanced features we offer, because when you think how much logic you need to do in a background, it's really extremely complicated. And maybe the last thing I'm going to show today, I don't think I can do all of that, is how we are working with an NFT hackathon challenges you can participate in. We, of course, are working with NFTs. We have a lot of things prepared for you on the NFT side. And one of the most coolest thing we have is basically minting NFTs like in one API call. We already have a deployed contract on a Klaytn network. We already provide you, or like internally, we have a private key with the Klaytn funds on it, and we are minting NFTs for you where we are covering the cost. You don't need to do anything. You don't need to provide private key. You don't need to fund. You don't need to deploy your collection. You just say to whom you want to mint who you want to mint NFT and what's the metadata. I suppose the metadata will be some IPFS URL where you can like deploy your metadata, and you just hit the send and the NFT is minted. Like that simple it is. When we check the transaction, again in the Explorer, we can see that we have minted one NFT from address 0 to myself, and there are some details about the NFT as well, I suppose. We can check it. We can see the metadata URL, we can see everything. So with this, let's say, operation, if you want to just build something fast, you don't care what's the collection, you just want to mint some NFTs, you can mint them on top of our contract. If you don't want to mint them on top of our contract, then you can mint by yourself. You can easily deploy a new NFT collection contract where you use the NFT deploy operation, where you just use the name and the symbol and the chain. And the result is, again, the transaction ID of the deployed contract. We can get this transaction ID and programmatically obtain the address of the contract from the transaction. And this address is actually your own deployed NFT collection. Right now, you won't see anything here. So let's mint token number 1 on top of this newly minted NFT collection, and we're going to mint the token to ourselves. So let's mint 1 token with ID 1. Again, we have used NFT mint operation, so the same operation as for the Express, but we have expanded the payload with the private key from which we want to mint the contract and the identifier of the token. So a little bit more information, but gives you more flexibility. So let's check this transaction, and we can see that we have minted one NFT, Klaymakers22, and we have minted it to ourselves. And the last operation I'm going to show you today is actually that you can transfer the NFT we have minted via the NFT transaction, where you say on which collection you want to call, which NFT you want to transfer, and who's the new recipient of the NFT. You just hit the send, and the NFT was transferred again. So when we check the transaction, we're going to see that we have transferred NFT. Yes, we have transferred it to ourselves, but that's not important. We can see also in the history of the NFT what was happening and what's the history and how the NFT traversed between the different owners. So this is again another nice section of the platform I've shown you. It again removes a lot of complexity from your hands, because you don't have to think about the contract to deploy, how to deploy it, what's the parameters, etc., etc., etc. You can just work with that, and it's working. And for those who don't want to use private keys and API calls, which is always correct, and for those people who want to leverage the custodial application and they want to build custodial apps, we have a nice tool which is called Tatum KMS, which is your own ready-made key management system, which could run on your end locally. You store private keys there, and the KMS is signing the transactions. And with the KMS setup, you basically replace the private key with some identifier of the wallet, and the transaction will be signed inside the KMS. But I don't have enough time to show you all the details, but you can find a lot of information about the KMS on our KMS GitHub page or in our docs, where you can check out how the key management is working. And here there is a lot of guides about other things and other features of the platform. So to sum it up, there is a Tatum challenge available for the workshop where you can win up to $10,000, and you can leverage any of our offering for Klaytn. You can leverage the RPC nodes, you can leverage abstractions, you can play around with our SDK or KMS. So basically whatever you're gonna build and you wanna mint, you wanna build and you're gonna use Tatum framework, you can participate in the challenge. So thank you, and Chris, back to you.
Awesome. Yeah, thank you very much, Samuel. One question is that what is the currently biggest challenge or probably the most confusing things from your observations for developers to building a dApp, maybe not only through the Tatum but from or in general pictures of the whole industries.
Yeah, like in general, what I see and what I see from discussion with a lot of developers and projects out there is basically the choice between the custodial and non-custodial setup, right? Because they don't know how they want to approach, because both has some pros and cons, right? Obviously, the pros of non-custodial approach is that it's like truly Web3 and you own your private keys and everything, but there is a huge con that like only 1% of population can actually work with this kind of application, right? So if you want to onboard like millions of people into your app, you just don't want to force them to create some MetaMask wallets, right? You're just going to start with some custodial setup and educate them. So like this is the biggest thing. And everyone is asking, what should I do? How should I approach? And a lot of people are asking these questions.
Got it. Yeah, and do you think from this perspective, like Tatum can add some special value for by tackle this problems issues?
We offer developers both ways, or even the hybrid way, where we are standing somewhere in the middle, right? We offer them a full suite of tools for building custodial applications. For example, that key management system I was talking at the end is basically a ready system for any custodial app. And as well as we give them the power to communicate or prepare transactions for MetaMask signing and for fully decentralized applications. So they can always choose what they want to do. We don't like limit them in either way, but on top of that, we give them some, let's say, operations which are not custodial or non-custodial, which are general operations like read NFTs by address or these kind of things where they need this information in both cases. So they're not limited in any way.
Got it. Cool. Yeah. So I guess there's no more questions from my side, and since it's like a 1 hour workshop, I think it's pretty fair enough to end it up here. I would like to thank to Albert and Samuel for bringing us such a wonderful developer workshops today. I believe this is super helpful for all of the audience and developers who are listening to this workshop to better understand about the challenge and also about the BlockPI and Tatum itself. So there will be many ambitious moves for Klaytn in this year's, and this hackathon, which actually we call it as a flagship hackathon, will be one of the most important parts for Klaytn's developer plans this year's. And as Dorahacks, we are very excited to be part of it and very glad to support the Klaytn and also Klaymakers for global developers who want to build on top of the Klaytn blockchain. So if you want to know more details, please stay tuned. Check the Klaytn Foundation Klaymakers website and join our Discord. Feel free to ask any questions from there. We are very happy to answer those for you guys. And in the future, we will have a series of the workshops like today's. So if you are interested and you haven't followed us on YouTube or Binance Labs, please make sure you do that so you will miss out any of the upcoming sessions that we are about to host for you, like today's. And if you have any ideas that want to be tested out on Klaytn, like I mentioned, Klaymakers will officially start on the next Monday. So keep your eyes on our social channels. We will update the newest progress about the whole Klaymaker hackathons, and seize as a chance to join this hackathon with a bunch of the prize rewards and following up support by many versions. Yeah, and I would like to thanks again for everyone who joined us. Special thanks for Samuel and Albert again. And hopefully you guys can all doing great in the future. And we are really looking forward to see you all in the Klaymaker Hackathon. Yeah, thank you guys very much.
Thank you.
Thank you, guys.
Thank you. Have a
Thank
good
you.
one.
See ya.
Bless you.